today you're going to do vertical and horizontal translations. Okay, the first thing you need to do is go through and put these into your y equals menu of your calculator. So y sub 1, y sub 2, y sub 3, and so on. I don't have those in subscript form. Okay, but we want to get those in there.
How do you do the absolute value?
Let's wait for everyone to get to the absolute value if we could. Okay, how many of you have the first three in? Okay, I'm gonna pause you right there then if you have the first three in. First three, we have our x, we have our x plus 1, and our x minus 3. Please note that when I enter something in there, what I end up getting is this equal sign highlighted when I start typing, which means if I hit graph right now, all three of those things would graph because the equal sign's highlighted. I'm going to cruise on over to the equal sign on y sub 2 and hit enter, and that's going to turn off that graph. And hit enter on y sub 3 and turn off that graph. Now when I hit graph, the only thing that's going to graph is y sub 1. Okay? And that's the y equals x graph. Alright? Now, what type of graph is that? Good, that's linear. So if you had forgotten that that's linear, it might be something that you want to write in right now. This is called a linear function. Okay? Something you studied a lot when you were in algebra. In fact, all of these right here belong to the family of functions called linear equations. Okay? They are linear. This function right here, the first one we graphed, is called the parent function. Okay, it's the parent function. And the parent function, from that parent function, what we can do is we can go through and get all these other graphs by shifting it in some way. Okay, so for instance, right now I have y equals x on my display. If I want to graph the next one, if I go to my y equals menu, and I hit enter for y equals x plus 1, what happened to my graph, the new graph now? Yeah, it went up. How far did it go up? 1. The lines are also parallel. Why are they parallel? Tell your neighbor why those lines are parallel. Okay, volunteer. Why are those lines parallel? Nick?
Because the m part of it and y plus mx plus b are the same.
Good. Did everyone hear that over there? Why are they parallel? Someone over here. They have the same slope. The m is the same. Okay, so all these should be parallel. What do you think is going to happen if I graph this one? It's going to be below the parent function. In fact, it's going to drop the parent function 3 units, right? Okay. This is called a k-shift. It's just moving your graph up and down the y-axis. That's what's happened there. And in linear functions, we usually don't really talk about h and k shifts. Because we know linear is in the form of y equals mx plus b. So we usually leave it in that form. Y equals mx plus b. It's an easy form to graph, but if you wanted to put it in point slope form, we could, and we could do hk shifts that way. We're not going to really do that with them. You guys are pretty good with linear. We're going to leave it at that. However, if I go back here now and I graph my x squared, so here I'm going to punch in my x. Remember the squared button is right here. Okay? It's just below, a couple below the math button, 2 below the math. We hit squared. And then I put my plus 2. And then, oops, I forgot I need to just put the x squared one first. So I'm going to go there and hit delete. All right. If I want to clear a whole line, I could just hit clear. If I want to delete a certain item, just hit delete. Okay? So we got our x squared plus 2 and our x squared minus 1. No, minus 4. Excuse me.
Can't really see it.
Okay. Thank you. Thanks for telling me. All right. So now, go ahead and tell your neighbor what you think is going to happen before you look at the graphs to the +2 and the -4. Hey, time's up. Hey, there's my parent function for y equals x squared. Y equals x squared, I have my parent function. Notice it's a parabola. We call this type of function, what is this? It's called a quadratic. Good. Quadratic. How do we know something is a quadratic? Someone new? Yes? It has exponents. So x to the 5th is a quadratic? I'm being difficult a little. More specific exponent. Has an x squared. Good. So it's in the form of y equals x squared. It has that squared. That squared sign right there tells us it's quadratic. Okay. Fun bell there. So we'll go back here. I'm going to put the +2. And that shifts my graph up 2 units. Okay? Very good. How many predicted that would happen? Did it do anything else to the graph? Nick?
Is it more narrow or more wide?
Is it? More narrow or wide? Sometimes I get that. Really, if I shift this part upward, the narrow part actually shifts up. So it's not narrow, it's not more narrow or wide, it just kind of looks that way because the narrow part shifted up. So we don't see the whole graph. Okay? But that is something that we sometimes might observe and think is happening, but it's not actually happening there. Okay, and if I hit that one, let me turn this one off. -4 should do what? Yeah, it drops it down. And it's not wider, it just means the graph shifted down, so it looks like it got a little wider because you can see more of it. Okay? All right. Now, linear is in the form of a straight line. A quadratic is in the form of a U-shape, kind of. Kind of a happy face there, all right? Or sad face. Okay. The last one is, anyone know what types of functions those are called? Those are called absolute values. Absolute values. And they are in the shape of a V for value. That's why they're, no, that's not why they're V, but yeah, it might be a way to remember it. They're in a V shape. Absolute value goes in that V shape, and when you're putting them into your calculator, oops. Thank you. When we're putting them into our calculator, let me turn these off. And this is something you should put. How many of you have that part of your notebook where you're keeping notes about your graphing calculator? Some of this stuff you may not need, but absolute value is one you won't use tons, and you'll want to try to remember where the key is for it. So you might want to put this part in that section. If you're not keeping a graphing calculator notebook because you're like too cool for that, dude, I don't do that because I don't need to. Okay, don't ask me later, but you really should write this down because, once again, it's a question I get a lot. So absolute value is right here. We go to math. It's not just a single key. It takes a few keystrokes. We go to math. And so if I'm taking notes on this, by the way, I put absolute value. And I would say the keystrokes are math. That's a button. Okay. And then from math, you go over one. You arrow over to the right. So there's my right arrow. I'm going to arrow over to NUM. So I'm going to show that by doing this. There's my arrow. And I'm going to select number, NUM. So if you want, you could put in parentheses what you're selecting. Sometimes it's hard to figure out what your notes say, but the little buttons are buttons. And then from there, what am I selecting? Yeah, option 1. Option 1, which happens to be abs. Now, they're not like your abs, you know, okay? They're abs. You hit enter, and there it is. There's your absolute value. Now, if you have a TI-83, you don't actually see the absolute value symbols. You see ABS with parenthesis open. Make sure you close that parenthesis when you're done. Otherwise, it'll keep putting everything you're typing in the absolute value symbol, and you don't want the 3 in there. Okay? If you have a newer version, you're going to see the absolute value. You put X, and then you arrow over so you can get outside of the absolute value bars there. You break out, man. Okay? Absolute value of X. And then math, number, abs, and X, and then arrow over or close the parenthesis and plus 3. And then math, number, abs, and X, arrow over minus 2. All right, now I'm going to turn them all off except for the first one, and I want you to tell your neighbor what's going to happen on these graphs, what you think should happen. Okay, volunteer, what should happen? Cody, what should happen with the X absolute value of X plus 3?
It'll make like a V.
Okay, it'll make like a V. And in relation to the parent function, what would it look like?
It'll just be shifted up and shifted down.
Okay, shifted up 3. Okay, and so you're saying this one would be shifted down 2. Everyone agree? Okay, how many are like, okay, I get it. We got it. Okay, really the form you're looking at in these, well first, are there questions before I go into the form? We've talked about y equals mx plus b here. That's as far as we're going with linear because you're pretty good with that. The forms we're going to be using for these two to graph them is what's called vertex form. And what we just did is what's called the k-shift of vertex form. So let me help you to summarize the k-shift by actually giving you vertex form for both of these. They're very similar. Okay, vertex form for a quadratic. Vertex form is that blurry, you guys? Whoa, that's really blurry. I don't know. All right. Vertex form is y equals a times the quantity, x minus h, quantity squared, plus k. Huh? You learned something like that, yeah. HK, yeah. Okay, vertex form for for an absolute value is y equals a times the absolute value of x minus h plus k. Now notice they are very similar forms. You'll notice the k. Well, first you'll notice both forms have parentheses or some kind of grouping symbols in them. You'll notice the k is always on the outside of those grouping symbols. That k shifts your graph along the what axis? The y-axis. So if I think of the x and y-axis, the k shift shifts it on the y-axis. The h shift, which is what we're about to study, shifts it on the x-axis. It's called the HK. Now really what we were paying attention to when we were doing HK today, really what you looked at was when we were looking at our graph, our H and our K was our vertex. That's the HK. That's why we call it vertex form. When you're dealing with an absolute value graph, your HK is right here. Once again, that's vertex form. That's the piece you're shifting, your vertex. In a linear graph, do you have a vertex? No. So you'd have to shift other things, and we're not worrying about that, okay? We're sticking with y equals mx plus b. The HK, h comes before k, x comes before y. All right? We try to remember that it goes in that order. Mr. Vogel and I, we talk about who cares. Who cares? Okay? HK. Yeah, man. Spelt wrong? Who cares, man? HK. All right. All right. Some of you are like, that's spelled right. Okay. If you're saying it's spelled right, we got other problems. All right. Any questions there? How many are with me so far? All right. Now, some of you are like, well, I don't even need to do anything else. McCoy, you just give me the assignment. I'm cranking away. I'm good to go. Dude, because I know that this is what type of shift now? That is our H shift, right? It's our H shift. So some of you look at that and you're going, this right here is my parent function. I know what that looks like. This right here is going to shift where and where? Tell your neighbor. All right. Tell them exactly where it's shifting to. Okay, now test your theory by throwing it into your calculator and see if you're right. All right, now that you have them in there, how many of you were able to make the correct prediction? How many of you predicted it went the wrong way? Okay, well, let's check it out. When I have +1, most of you would say, hey, that shifts my graph 1 unit to the right. And logically speaking, +1 is over here. However, that didn't shift my graph to the right. It shifted it to the left 1 unit. Which now, logically speaking, you go, okay, hold on, that shifted it to the left. What's the minus going to do?
Shift to the right.
Okay, so we might start looking for patterns like that because that's what we do. So we hit graph and we're like, okay, we got our x squared and maybe, hopefully, this one will shift it to the right 3 units. Whew. Yeah, dude. There's some kind of logic involved there. Okay? Well, that's true. This is actually, notice the form. This is x minus h. To get a positive number right there, that would mean that I would have had to have x minus -1 to make that a plus. Okay? The other way to think about it, and probably the easier way to think about it for students, is that this right here, you're really shifting your graph to the point that would make that quantity equal 0. So if I set x plus 1 equal to 0, what's the solution to that? -1. That's where your graph shifts to. If you set this equal to 0, what's the solution to that? 3. That's where your graph shifts to. It shifts 3 units to the right. Shifts 1 unit to the left. Okay? So what you need to remind yourself is that, hey, this being a quadratic, this shifts my graph that way 1 unit. This shifts my graph that way 3 units. It's backwards from what you would expect. And it's the same thing down here. Now we're running short on time. You could actually graph those and go through the same process, but I want to give you time to work. Okay? This, tell your neighbor where these are going to shift to. I've got them on my calculator and we'll blow them up. All right, here's the +3. Let's see if you're right. Absolute value, it's a V shape. +3 went to the left. Okay? Which means my -2 is going to go to the right, hopefully. Hopefully. Now, I don't know if I selected the right one. Yep, there we go. Okay. Very good. Any questions there? Okay. All right. Who cares, right? Okay, let's take a look at our assignment. So if you'll take your paper out, I want to talk to you about how we're going to do these. You should have graph paper, which you grabbed on the way in. On today's assignment, you get to cross out this portion, 4, 8, and 12 on the example side, as well as 24, 27, and 30 on the example side. So we're working only on the example side. Do not cross anything out on the mix. No, we're doing the example today. Mix this tomorrow. Okay? Example today. So cross those out. You have to do the rest of the example. Now, let's go through these. Some of you are very type A, like you can't skip numbers. And I get type A people. Okay? But you can't skip numbers. Like, I want to start with number 2. I want to go through that one with you. So if you are one of those people that don't like skipping, you can, hey, that's number 1, and then move to here. And now we'll skip to here. But you have number 1 still. And you have to do number 1 accurately. Y equals mx plus b. Do that correctly. But let's start with number 2. I want everyone to put on graph number 2 where your vertex would be. Where is your vertex going to be? Okay, now compare it with your neighbor. Where did you put the dot for your vertex? Okay, can anyone tell me where we put the dot? Trent?
At the one that's positive.
Good, at the one that's positive, so give me a coordinate, like an address.
0,
0, 1, right here. Okay, my graph shifts up 1 unit. Now remember, this is a x squared, which means it's a parabola. Okay, we have 0, 1 here. This is a parabola. Label your vertex, please. And it's a parabola. So for today only, you get to just, from there, draw a parabola. I don't care if any other point is accurate. It doesn't matter to me. What matters to me right now is your vertex is accurate. If you have parents or brothers or sisters who look over your shoulder when you're doing it, go, hey, you're doing it wrong. You're doing it wrong. Hey, no, that's right. Good job. You're doing it wrong. Okay? Just tell them today, all he cares about is that vertex and I have the correct shape. That's it. Okay? That's all I care about on this one. All right. Any questions there? So number 2's done. Number 1, you have to actually graph accurately because linear you're familiar with.
So just for the quadratics, 1 or 2 vertex?
Quadratics and absolute value. You have to do the vertex and the shape, the correct shape. Okay? Now, please note, we go all the way to 11. If you need a pre-number, go ahead, pre-number. You get down to 13 through 15, it says, write each equation of each translation of y equals x squared, and y. Okay, in other words, they're saying you translated these equations. So what seems to be confusing for students are the rest of the directions. So let's do this. Write the equation. Write the equation for each of those. That's what you do. All right? Numbers 16 through 21. One graph for each of those. Okay? So we had 9 graphs, 10, 11, 12, 13, 14, 15 graphs. There's 12 per page here. So we're now at 15. I'm going to go down to, 12, 13, 14, 15. Okay, now I'm down to the 16th graph, which is number 22. So on the back of your paper, if you're trying to stay in order, that one's number 22. That's the next one we're doing together. I'm just trying to give, if it helps you to pre-number, you could do that. If you just want to do it at the very top, that's fine. Yep, you are doing 21. I'm doing 22 with you right now, though, as a class. 22. 22 says f of x equals x minus 2 quantity squared minus 1. All right, I want you to put where the vertex is without looking at your neighbor's paper. Okay, now if you're waiting to ask your neighbor, just put a dot on your paper somewhere so you have a horse to root for, man. Like if you're at the horse races, you had something to root for. Okay. You have a team to root for. You're like, I hope it's right here. Okay? You have 100 dots there. Dude. Okay? Show your neighbor. All right, volunteer to tell me where we put it. Someone that hasn't participated today. Claudia, what do you got? -1 on x, 2 on y. You sure it's not 2 -1? So 2 on x, 1 on y. So this part right here, inside the parentheses, is our x shift. Okay, so this is our horizontal, and this is our vertical. So we may have had it backwards there. So we go 2 on x, 1 on y. There's where it is. The ordered pair 2, 1. Okay, how many had that? How many didn't have that? Uh-oh. Dude. What's wrong with it? Yes, it is -1. Okay, the two most common mistakes that happen are we flip them, which I think is what Claudia was doing. You had him twist it around. Okay. And the other mistake is that students start messing this part up. They start going, well, I got to change that sign, so I have to change that one too. You don't change this one. Okay, this shouldn't be at +1. It should be at -1. This should be at 2, -1. Now, how many of you had that? Okay, very good. All right, so we didn't have tons of you making the mistake, and that's good. From there, remember, it's a parabola. Okay? I don't care about any other points. Tomorrow, we're going to be accurate with the other points. Today, we're not worrying about it. Okay? What type of shape is 25? It's a V shape. Okay. Very good. You have your assignment? Go ahead.